All right, so today we are looking at our next topic. So, vectors, as it says here, vectors. So, first question is, what is a vector? And so, the definition of a vector is here in this next line. So, it's a quantity that has a size or a magnitude, it's often referred to, and a direction. All right, so it points somewhere and it's certain big. So, on the Cartesian plane, vectors can be represented by arrows, and so directed line segment is another term that's used. And so here we've got a few here. So A, B, C, D, E, F, they're all vectors. And so, we will write, so I'll look at AB, for example, AB, so that we know it's a vector. We put a little arrow at the top there, and that's the vector that goes from A to B. All right, so it's from A to B, so we know that direction. All right, then same with those other things. Now, when you have a look at A and B and C and D, you can see they're parallel to each other. They're pointing in the same direction, in fact, even. And it looks like their lengths are the same. So for the purposes of this, AB and CD are considered equivalent. All right, so they're considered to be the same, even though they start where they start and finish is different spots. That doesn't matter. The fact is that they point the same direction, they're the same length, so they're the same vector. There is a series of vectors that we'll get to called position vectors, where that kind of is a little bit different to what I've just said, but these ones here that start and finish in any random, well, they're any random starting point, we consider them to be equivalent to each other. All right, I'm starting to waffle, so let's move on. Now we can also represent vectors, as it says here, as a column. So 3 on 2 above 2, and so the 3 represents we move from wherever we start, we move 3 units to the right, and the 2 units up. So if here we start here, and we go 3 units to the right, and then we go 2 units up, and we end up there, and the vector goes from where we started to where we finish. All right, and so that's what we would refer to as a column vector. All right, so it always tells us right. Left, of course, would be negative, and then up and down, of course, would be negative as well. All right. Now, sometimes it's handy to have both letters, A, B, but sometimes it's easier if we just use a single letter. And so AB with their single letter V with this little squiggle underneath, here indicates that V is a vector. And so you've defined vector V, which is the same as vector A. So sometimes it's simpler to have a single letter, other times 2 letters. It just depends on what we are doing. So if you've got a few vectors and you've got lots of letters, it can start looking a bit confusing, but so sometimes we use that. All right, so what do we got to do? Let's have a look at a bit of an example. So let's scroll into the next one. Here we go. Oh, excuse me. So the vector U is defined as the line from 2, 6 to 3, 1. And if U is written as a column vector A on B, find A on B. All right, so there's a couple of different ways we can do it. We can say draw a Cartesian plane, and 2, 6 is up here. That's where we start, and 3, 1 is down here. That's where we finish, and so the vector we're after goes from there down to there. All right, so if I change the colour and I say, all right, well, I've come down here to there, and so from 6, so I've come down -5, and then I'll go across, and I've gone across 1. So this particular vector, then I could say it's -5 down and 1 across to the right. And so I could then write that vector as -5, 1. Now, we could also, alternatively, we could also write the vector in the following way. So our final position minus our initial position. So our final position is 3, 1, and our initial position is 6. Sorry, yeah, I've got them the wrong. Yeah, sorry, 3. Got this the wrong way around, haven't I? It's across. Goes up the top, so we've gone across 1 and we've gone down 5. All right, so sorry about that. That's a mistake I shouldn't have made. All right, so at 3, 1, and we end up at 2, 6. And so when we just subtract those, we'll go 3 minus 2 is 1, 1 minus 6 is -5. All right, that's better, because we do the across horizontal in the top and the vertical is underneath. So that's how we do that as a column vector. All right, so now we're going to just start doing some things with vectors. So addition of vectors. So geometrically, so we can draw diagrams of those vectors, and then we can have a look. And it says here, vectors u and v are added by placing head to tail. All right, so here's my vector u, and I'm going to make that one then vector v. It says we place them head to tail. So if I'm going u plus v, I'll put vector u first, and that's where I end up. And then the tail of the next one, v, goes here. So there's u, there's v. And now it says the result is the vector from the start to the finish. So let me just change my colour. So vector from the start to the finish. We started there and we finished here. So vector u plus v is that one there in the orange. All right, and then if you want to know the length of it and other which things, directions it's pointing, etc., you'd use trigonometry. So whether that's SOHCAHTOA or sine rule, cos rule, or whatever, you use trigonometry to work that out. Now, another thing to note is that u plus v, which we've just worked out, is in fact the same as v plus u. All right, let's go different colour. Let's go purple. That's nice. So v points in this direction, and then u goes there, and so you end up at the same spot. All right, so for addition, u plus v, v plus u, they're the same. Column vectors, if you're adding column vectors, well, I've subtracted column vectors there. Adding is again just like we do with matrices. So we would just add the elements, corresponding elements together. So that one's a little bit more straightforward. Now, the next bit that we get to is subtraction. So subtraction is a bit more tricky to do geometrically. But what we do is we do a little bit of a modification, if you like, to the sum. And so if, for example, I have u minus v, let me get rid of those dots, u minus v, then as it says here, rewrite the subtraction in terms of addition. So what we do is we rewrite u in terms of addition. What are we adding? We're adding the negative of v. All right, so if v points this way, then negative v points completely the opposite direction. All right, so if we've got two vectors, so vector u and vector v like we had before, then vector negative v, of course, is this way. And so then when we add the vectors together, we go at u plus the negative v, and then from where we started to where we finished, that one there is the u minus v. All right, and again, so we rewrite it, we draw the diagram, and then again, as we did with the other one, we'd use, trigonometry to work out the various sizes, angles, etc. All right, so let's have a look at a vector, some vectors, some column vectors, and do some stuff with them. So here for these column vectors, it says u is 3, 1, and v is negative 2, 2. Find 2u plus 3v. All right, so it's just a matter of doing two lots of u, which is 3, negative 1. And to that, we're adding 3 lots of v, which is negative 2, 2. All right, so multiply each of those elements by 2, and you get 6, negative 2. Each of those by 3, and you get negative 6, 6. And then we just add, so 6 plus negative 6 is 0. And minus 2 plus 6 is 4. So there's the result of those vectors. So column vectors, a lot more straightforward than doing it geometrically. All right, so vectors are parallel. So the definition here, two vectors are parallel if they have the same or the opposite directions. All right, so that and that, oops, are not parallel. That vector and that vector are parallel, but then they're also parallel to that one because they're all lie in that same line. All right, so mathematically, u and v are parallel if u is some multiple of v, where that number can be anything except 0. So if it's bigger than 1, the vector's longer. If it's negative, the vector points in the other way. If it's between 0 and 1, the vector's shorter. But provided you can get one vector by multiplying the other vector by some number, then they're parallel. All right, now kind of hinted at these vectors before. Look at that, left myself a lot of space. Position vectors, where are they? There they are. There, went too far. Position vectors, there you go. All right, so position vectors don't have any random starting point. And so they write the position of a point relative to the origin. So on the Cartesian plane, we mean exactly that. So this here is our origin, this is O, and so position vector. So written here, this one's OA, and O represents the origin. So every time you've got a vector written that's got O at the front, then it's a position vector. And so OA might be there. And so this point here, point A, you would know its coordinates, say 2, 1, for example. And so then that vector there is vector OA. All right, so if we've got a point over here, point B, and then from the origin, that's its position, that's OB. And again, you might know its coordinates. For example, I don't know what they are. Let's make something up. Let's say that's 5, -3. All right, so it tells you the position of point B in relation to the origin, the position of point A in relation to the origin. All right, so then we can actually use our vectors to locate, other than just our vectors telling us how much the thing's changed by and in what direction it changed. Now we know exactly the location because we know a starting point. And they all have O because they're all from the origin. All right, and we'll do a bit more with position vectors in later lessons. All right, the last thing we can do is we can use vectors in geometric things, and we're just going to do something very, well, I won't say very simple, but more simple than some of the other stuff we're going to do. So here's, we've got ABC, and that's vertices of triangle, and DB the midpoint. So first thing I would do is draw myself a triangle. So there's my triangle, ABC. Then D is the midpoint of BC. Here's BC. So that spot there, that's spot D, and we know that's the midpoint. Then both of those would be equal. Then it says vector A, little a, is equal to AB. So AB is here, and that's vector little a. So right, I'm just going to get a different colour here. So vector little a points there. The other thing it says, vector little b is equal to B to C. So vector little b points that way. And so what we're going to do is for all of these things we're going to find out, these other vectors, we're going to do in terms of these two. So for part A, B to D, well, when we look at that, B to D is halfway from B to C. So we can say it's a half B to C. And B to C was what little b was, so that's a half of little b. All right, then B, D to C. All right, D to C goes from here to here. Again, that's half of B to C. So it's a half of B, little b. All right, next one, A to C. All right, A to C. All right, so A to C goes straight across there. Now, that's one way of getting from A to C. The other way would be to go around. So A to C is the same as going from A to B and then going B to C. All right, the result's the same. You end up in the same spot, whether you go straight or whether you go around the world. But we've gone around the world because these A to B and B to C have got some other names, if you like, A and B, and so that's vector A plus vector B. All right, A to D. All right, so A to D. Let's have a look at that. A to D. Let's go that colour. So A to D is this vector. All right, so how can we get there? How can we get? Right, how we can get from A to D? Well, we can go from A to B, and then we can go from B to D. So we can go from A to B. Oops, A to D is A to B plus B to D. Now A to B we know is little vector A, and B to D we figured that out before up the top here, and that's a half B. There it is. All right, then the last one, C to A, E. C to A. Now C to A is going this way, which is the opposite direction to A to C. It's the same line, length, but opposite direction. So that's the negative of vector A plus vector B, which is negative A minus B. All right, and so there we go. There's all of these vectors here expressed in terms of those other vectors. And when we get in subsequent further lessons down the track, we'll be doing things like that a lot more. All right, so have fun with the initial vectors in the first exercise. If you need assistance, make sure you get some help, and as always, have fun.